Dear students, welcome to Quantitative Techniques and Operation Research. So today we are going to see a topic called linear programming problem. So in the linear programming problem, we have major two steps. We have one is formulation and then we have to find the solution. So in the previous video, we have already discussed how to do the formulation. In the formulation, first we have to find objective function, constraints, conditions subject to, third is non-negativity, and complete the solution. So for completing the solution, so for that we have to use either graphical method or simplex method. So these two methods are very important in that. Okay, so today we are going for graphical method. In the graphical method, we have three concepts. One is maximization, linear programming, minimization, and mixed constraints we have. So three concepts we have. So today we are going for maximization. So what do you mean by maximization? So means graphical method when we have to use in the company means in the operations. So it's related to fully operations. So in operations what it deals with is in production. So in your company you are producing, imagine if you are producing many products. So we'll compare two products, product A and product B. So how much unit of product A we have to produce, so how much unit of product B we have to produce to get the maximum profit. So this is what it will help us to find how much unit of product A and product B we have to produce. The graphical method will help us. So linear programming. So maximization means what? So if you produce a product A, if you produce product A and if you produce product B, individually how much profit it will you can earn from that, it will show that. So maximization, which gives the maximum, which gives the more profit, that we have to choose as a feasible solution. So it's clear, students. So the concept is clear, So next we will go for illustration. It's an illustration to use the graphical method to solve the following linear programming problem. So next we have to use the graphical method. So maximize, they have given maximize z equal to 3x1 plus 2x2. So maximize means what? Is a maximization problem. So finally our main objective is to find the value of z. So that is a total profit. So it's equal to 3x1 plus 2x2 they have given. So here the x1 is a product A and x2 is a product B. So whatever finally we have to find what is how much unit of product x1 and how much unit of product x2 we have to produce. That is the final we are going to find by using graphical method. So whatever you are producing in the product means x1 if you are producing, if you multiply with 3, that is a profit you are getting from product x1. So it's the total profit you are getting in product x1. So if you whatever units of product x2 if you are producing, if you multiply into 2, so that is a total profit of x2 you are getting. So if you add x1 profit and x2 product profit, so you will get total profit. So this is the main solution we are going to find. So next they have given subject to the restrictions they have given. It means conditions. So producing product x1 and product x2, there isn't some restrictions or conditions are there, constraints they have given. So the first restriction is 2x1 plus x2 is less than or equal to 40. It means what? If you are producing x1 product, it's a 2 times of cost. If you are producing plus x2 if you multiply into 1, so if they are not given any number, we have to consider it as 1. So 2x2 x2 if you multiply with 1, this is a cost. So for producing that x1 and x2, the cost should be less than or equal to 40 only. It should not go more than that. So that is the concept of first constraints, restrictions. 2 times of x1 plus 1 time of x2 if you are producing, the cost should be less than or equal to 40. So it's clear, students. So next, 1 unit of means 1 portion of x1 plus 1 unit of x2 if you are producing together, it should be less than or equal to 24. So this is the concept of second condition. So next we have two portions of x1 plus 3 portions of x2 if you are producing, no, it should be less than or equal to 60. So these are the 3 conditions they have given, and x1 plus x2 is equal to 0. It's a non-negativity function. So it always what you are going to find the value of x1 and x2, no, how much unit of x1 and x2, the final answer should be value of x1 and x2 should be more than, it's equal to 0 or more than 0. So that is the concept of non-negativity. So next we have to find the solution. So next we are going for solution. So first in the solution, no, we have objective functions they have given as z equal to 3x1 plus 2x2, and conditions they have given, constraints they have given, 3 constraints they have given, non-negative also they have given. So next we have to, for graphical method, no, we have to find the equation. For the purpose of plotting the above equation on the graph, 1, convert inequalities into equalities and find out the point of line. So first we have to convert the constraint into equation. So we can finally solve the solution. So how to frame the equation? So they have given 3 restrictions, constraints they have given. 2x1 plus x2 less than or equal to 40 they have given. So here we have to make it as equal, means equations we have, so equal to 40. So next we have x1 plus x2 is less than 24, no, it here equal to 24. The next one, third one is less than 60 they have given, so equal to 60. So these are the 3 equations. So we have converted inequalities into equalities, means equation. So this is the objective function, first equation, second equation and third equation. So we have converted inequalities into equation. It's clear, students. So next we'll find the value of points, means the point 1, no, x1, and point 2 is x2. So in the point so in the first equation they says that 2x1 plus x2 is equal to 40. So here, no, in the first point, no, in the graph, no, there are x-axis and y-axis, 2 axes they have. So in the x1 axis, so here, no, x1 axis and x2 axis we have. In the point 1, 100%. So in the first we have to find x1 axis. According to first equation, no, 2 times of x1 plus 1 time of x2 is equal to 40. So in the point 1, no, we have to consider if we are producing only product x1. So what is the total value of that x1 we have to find. So here including 2 times of x1 plus 1 time of x2 is equal to only 40. So if you are producing only product x1, so only product x1. So what is the value, how many units of x1 you are going to produce. So this is an equation, no? So I have made a note. So how to show that? Means 2x1 plus, so here in the formula they have given x2, no? So here we are not considering x2. So if you are producing only x1, what is the value of x1? So 2x1 plus 0 is equal to 40. So we are removing that x2 value, product x2 we are all removing that. So your 2x1 is equal to 40 you will get. So if you are producing certain amount of units of x1, so product x1, if you multiply into 2 only, it's equal to 40. So how to find the value of x1? So we have to divide x1 equal to 40 divided by 2. So if you divide 40 divided by 2, no, so your value of x1 is equal to 20. So it's clear, students, how to find the value of x1. So in simple, whatever equal to 40 they have given, no, whatever value is there in the value of x1, no, you just divide that total, means equal to 40, no, divided by 2. If you multiply, no, you will get what is the value of x1. So 20. So next in the point of 2, no, here we'll 100%, we'll consider if you are producing only product x2, we are not considering x1 here. So 0 have taken. So whatever 0 if you are producing into 2, if you multiply also it's 0 only, it's equal to 2x2 divided equal to 40. So here there is no number, it's only 1, so x2 is equal to 40. So it's clear, students, how to find the value of x1 and x2. This is only 100%, if you are producing only product x1, if you are producing only product x2. So this is in units you are going to produce. So in the second equation, no, x1 plus x2 is equal to 24. So here x1 also 24 and x2 also 24. In the third equation they have given 2x1 plus 3x2 is equal to 60. So in the x1 value, no, 60 divided by 2. So your value of x1 is 30. So in the x2 value, no, 60 divided by 3. So 20. So this is the value you are getting. So it's clear, students, how to find. So next, this is the table we have found the value of x1 and x2, no, at the point of x1 and x2. So next we will draw in by using graph, no, how to draw a line I will show you. So this is the line, it's a 0 point where this is an x1 axis and this is a x2 axis. So here they have given value of x1 and x2, no, 20, 40, 24, 24, 30, 20 they have given. So it's they have given till 40, no, so we will take 10, 20, 30. So if you means you can take 5, 10, 15 also, or 10, 20, 30 also you can take. So always, students, whenever you are pointing, means plotting, means you are taking the values of numbers, no, always in the x axis what are the values you are taking, the same value you have to take in the x2 axis also. 10, 20, 30, 40, 60, 50, 60, 10, 20, 30, 40, 50, 60. So same values I have taken. So this is the main. So next we will draw a line. So here, no, in the point x1, in the point 1, x1, no, it's a 20, and in the first equation, you can see the first equation, the value of x1 is 20 and value of x2 is 40. So 20 to 40 we have to draw a line. So this is a rough diagram how to draw in the graph sheet, no, I am explaining. So you have to use the sharp pencil to, you have to draw correctly. So 20 to 40 we have to draw a line. So it's the first equation. The second equation is x1 is 24 and x2 also is 24. So in the 24 point, no, we have to draw one more line. So next x1 is 30 and x2 is 20. So 20 to 30 we have to draw one more line. So this is a means basic. So this is a line we have drawn. So from this, no, first we have to find the feasible region. So in the constraints, no, in the main question they have given all three are less than 40, less than or equal to 40, less than or equal to 24, less than or equal to 60 they have given. All three are less than or equal, no. So for that, no, we have drawn 3 lines. So which is the least one? So we have to find the feasible region. It should be, we have drawn three lines, it should be less than that. So whatever line we have drawn, no, it's less than that, we have to find the feasible region. So for that less than, no, 0 is the least one. So it when compared to all three lines, no, 0 is the least point. So first we have to find that. Next point is in the x axis, no, x1 axis. So you have 3 lines we have we have drawn at the point of 20, 24 and 30. So which is the least one? So when compared to all 3, no, 20th point is the least one. So that there we have to point a line. We have to point. So next is where actually the point is meeting. That is the major points we have to, least point. So next point is here. And next point is here, next point is here. So you can see that 0, 20 and some 2 points is here, and in the next point is in 20. So we'll give the name for that each point. So 0, A, B, C and D. You can clearly see that. So these are the feasible region. Actually next we have to find where actually the point is meeting, no, that is a extreme points. So I have drawn in the graph sheet so that you can correctly identify where actually the point is meeting. So 0, A, B, C and D. So next we have to draw a table showing all the extreme points and what are the value of x1 and x2. It's a coordinates. So value of 0. So at the point of 0, no, here is a 0. What is the value of x1 and x2? It's both are in the same point. So the value of x1 is also 0 and value of x2 also is 0. So next value of A. Next the value of A, it's on x1 axis. So if you draw a line, no, in the value of x1 is 20 and value of x2 is 0. So your value of x1 is 20 and value of x2 is 0. So next we have going for B. So you can see that the B point is meeting here. If you draw a line towards x1 axis and x2 axis, no, if you draw a line, you can see it straight to B, no, I have drawn true lines. So where actually the x1 line is meeting, means x1 axis is, the point is meeting at the point of 16. So each box has 10 lines. So one line is for one point. So after means if you count, no, 1 2 3 4 5 6, means 16th line it is going. So it is in point 16, it is meeting in the x1 axis. In the point 2, no, it's 8. So value of x1 is 16 and value of x2 is 8. So next we will go for C point. So in the C point, no, we can means I have drawn a line towards x1 and x2. So both are meeting at 12 12. So value of x1 and x2 both are 12. So in the point of D. So in the point of D, no, the value of x1 is 0 and value of x2 is 20. So 0 and 20. It's clear, students, how to find the value of x1 and x2. So this is a final graph what you have to show in the examination point exam. So this is the feasible region. So we have to shade all the feasible region and we have to write it's a feasible region. So it's clear, students, how to draw a line and how to find the value of x1 and x2. Next we will find the solution by using a formula. So these are the extreme points we have got: 0, A, B, C, D, and coordinates. Value of x1 and x2 we have got. Objective function z equal to 3x1 plus 2x2 they have given. So if you put this values of if you multiply, no, we can find the value of z. So in the first one, no, and the value of x1 is 0 and x2 also is 0. So 3 into 0 plus 2 into 0 is 0 is equal to 0. So next we have value of x1 is 20, x2 is 0. So 3 into 20. So I have used the formula z equal to 3x1 plus 2x2 is there, no. So value of x1 and x2 only I am taking from this coordinates. So 3 into 20 is 60 plus 2 into 0 is 0. So it's equal to 60. So next 16 and 18 we have found. So 3 into 16 is 48, 2 into 8 is 16. So if you add these two, no, it's 64. So next 3 into 12 plus 2 into 12 is equal to 36 plus 24 is 60. Next value of x1 is 0 and x2 is 20. So 3 into 0 is 0 plus 2 into 20 is 40 is equal to 40. So from 5 extreme points we have found. In this, no, we have found the value, we have used a objective function formula also. When compared to all these 5, no, actually this is a maximization problem, no. If you produce 0, in the A point, no, if you produce 20 units of x1 product, units of x1 and 0 units of x2, no, so you will get 60 rupees as a profit. So next in the B point, no, 16 units of x1 and 8 units of x2 if you produce, no, you will get 64 as a profit. In the C point, no, 12 units of x1 and 12 units of x2 if you produce, so you will get 60 rupees as a profit. In the D point, no, 0 unit of x1, so you are not producing x1, only if you are producing x2 product, 20 units of x2 product, no, so you will get 40 rupees as a profit. And compared to all, no, which is the maximum? This is 64 is the maximum, no, so at the point of B. So if you produce 16 units of x1 product and 8 units of x2 product if you produce, so you will get 64 rupees as a profit. So that we have to choose. So that is the main solution. From using that formula we have found the value. So maximum value of objective function z equal to 64 occurs at the extreme point B, 16 and 8. Hence optimum solution to the given linear program problem is, so your x1 means the value of x1 value is 16 and x2 value is 8. So z equal to 3 into 16 plus 2 into 8 if you multiply, no, so you will get z equal to 64. So this is the final solution. So it's clear, students. So from this we can from this graphical method we can say that if you produce 16 units of x1 and 8 units of x2, no, so you will get maximum profit, 64 rupees as a profit you will get. So it's clear, students, how to find linear programming by using graphical method. Okay, it's clear, students. So if you have any doubt now, you can contact me. So try to solve this problem. It's in July, it's a previous year question paper, July 2018 question paper problem. They asked for 5 marks. Use the graphical method to solve the following linear programming. So maximize z. So it's a maximize, they have already given, it means maximization problem is equal to 5x1 plus 4x2. So it's an objective function subject to, it means constraints. 4x1 plus x2 is less than or equal to 40. 2x1 plus 3x2 is less than or equal to 90. So they have given 2 constraints. So in the graph, no, you have to draw only 2 lines. So we have to find less than that. So first we have to find the feasible region and mark the extreme points and find the solution. So whereas x1 and x2 is greater or equal to 0. So it's clear, students. Try to solve this problem. So if you have any doubt, no, you can contact me. Thank you.